So कौन से which paper question किस paper के?
सर ये है 4 to winter 19.
अच्छा just 1 second. अच्छा ठीक है, so 4 to winter 19. Winter 19 question paper. अच्छा which question?
सर क्वेश्चन नंबर 1 का पार्ट बी का 3.
अच्छा 1 part B, ये वाला B or 2?
जी थर्ड पार्ट.
अच्छा, so this third part, right? The equation of the overall cell reaction that occurs. So I mean, we would have to go through the whole question. The cell is operated. There's a Br2, Br minus 1 half cell, which has. Tell me. And there's a Mn 2 3 plus 2 plus half cell. Okay, so you've got 2 electrodes, and so I'm going to write those 2 electrodes. So there's Br2 plus 2 electrons. And it's in equilibrium with 2 Br minus 1. Okay, whatever that potential is, this is I think 0.54 volts. You confirm kar dena, okay, if this is 0.54 volts. And you've got the other one, which is Mn3 plus and 2 plus. So Mn3 plus gaining 1 electron, a reversible, and so gaining 1 electron reversible forms Mn2 plus and vice versa. Iska kya hai? What's the E naught for this one?
Sir 1.49 I think.
Okay, just 1 second. Acha, so so this one over here is 1.49, right? So you're supposed to make the overall equation. So what is the overall equation? Higher potential would gain electrons and the lower potential would lose electrons. Okay. Now, I don't think the potential would change that much, although the concentration is different. But if the potential difference is a lot, then the higher potential would obviously remain the higher potential, no matter how this changes, even if the concentration is different. So write the overall reaction of this particular cell. So you just have to multiply this by 2. What's the confusion in this one? This is
सर को मार्किंग स्कीम में पता नहीं 2 इक्वेशंस करके लिखा था. समझ नहीं आ रहा.
Just 1 second. 2Br minus 1 turning into the other reactant is. The other reactant is 2Mn3 plus. And the product you have is Br2 and the other one is 2Mn2 plus. Okay. So please ये mic mute कर लो, वो space bar से ना, you can unmute yourself. अच्छा, so yeah, so I'll just quickly check. I mean, that's it. I don't think the cell is operated. There's an Mn3 plus, Mn2 plus. So I don't think there's any complication in this question, but I'll just quickly check what the marking scheme states. 1B part 3, right?
Yeah.
So it's this one. TK, you've got he's saying that what is going on over here? He's saying Mn3 plus reacts with 2Br minus 1 and forms Mn2 plus. I think the only what is going on over here? I'm pretty sure there must be an error in the marking scheme because there's nothing into this question. I mean, what's the difference between these 2 equations? I think the second one is definitely wrong. वो देख लो, the second one is it's not even balanced. So I think there's an error in the marking scheme. There's nothing. I mean, you've got 2m and c plus on one side, you've got 1m and 2 plus on the other side. So I mean, it's obviously wrong. So there's an issue with the marking scheme in this one. Otherwise, the question is pretty straightforward. TK, is that clear? So what's the other? So part C of the same question, we've got an aqueous solution of copper to sulfate is electrolyzed using copper electrodes. A current of 1.5 ampere is passed for 3 hours. Now, using this, you can apply Q is equal to IT, and that would give you the charge, which is 1.5 amperes multiplied by time, which is 3 hours. 3 into 1 hour is 3600 seconds. So that's so what do you get for this? So that's going to be 1.5 into
16200.
1.6?
200.
So you're getting 16200 coulombs as the charge. Because you found the charge. And if you know the charge, you can figure out the moles of electrons. I don't even, I said they're not really interested in the moles of electron. They're more interested in the Avogadro constant. They're more interested in the Avogadro constant, which is L over here. So how do you link link charge to the Avogadro constant? What we're going to do with this is, because we have to figure out the Avogadro constant in this question. What we're going to do is I'm going to try and figure out how many moles of electrons this is, because they've told me that it's 5.09 grams of copper. So so to deposit 1 copper, you need 2 electrons. Okay, this is copper 2 sulfate. So copper 2 ions turning into copper. So I'll find the moles of copper. So the moles of copper getting deposited, that's 5.09 grams. That's on the other side. I'm going to divide by the MR, which is find the exact MR of copper, which is 63.5. Okay, so you're going to use that. So how many moles do you get?
0.08.
Exact?
Yes, 0.08015 आगे करके है.
ठीक है, उसको double करो, you'll get the moles of electrons. What do you get for that?
0.1603.
That's a 0.160. 3 moles of electrons. So sir, now we know.
Sir, यही moles of electrons हमारे पास कब से भी आ सकते कि if we use 1 mole of electron is 96.
So now the only I get your point. The only problem I'm not doing that is that I don't, because I can use the Faraday constant, right? But the Faraday constant is derived from the Avogadro's number, right? So because in the question, they're asking me to calculate experimentally the Avogadro constant. So I'm not trying to use the Faraday constant. I know that 1 mole of electrons is 96,500 coulombs, but it is only 96,500 coulombs if we use the Faraday constant. Avogadro's number. If I multiply the charge on 1 electron with the Avogadro's number, okay, what is the formula of Faraday constant? It depends on the Avogadro's constant, right? It's the charge on 1 electron multiplied by the moles, 1 mole of electrons, right? And you get the Faraday constant, which is why I'm avoiding the Faraday constant, because I don't know what the Avogadro constant is. I mean, the assumption to the question is we don't know what the Avogadro constant is. So because of that, we don't also know what the Faraday constant is. Do you get my point?
Yes, sir.
Okay, bro, is this clear?
जी. Okay.
So I'm going to avoid using both numbers, okay, because that's the one that we're trying to find out. Now, based on this, what we have figured out so far is, okay, I know that 0.1603 moles of electrons, right? Has what charge? It has 16,200 coulombs of charge, right? Now, I'm going to try and figure out the Faraday constant experimentally now. I mean, what is the Faraday constant? It's the charge on 1 mole of electrons, right? So I'm going to try and figure out the Faraday constant experimentally without using the Avogadro constant. I'm going to use ratios. What's the charge on 1 mole of electrons according to my experiment? So that is going to come out to be, if you use ratios, that's going to come out to be what, 16,200, and that's going to be divided by 0.1603. So what do we get for this?
13,961.
So 13,961.
Yes.
Which is like really far. I mean, that's really far away from 96,500 coulombs. But that is my experimental. That is my experimental value. I'm not sure if that is the correct one because it kind of looks really off. But let's assume that that is what you're getting. Now I found the Faraday constant, and using the Faraday constant, I'm going to figure out the Avogadro constant. So 13,961 coulombs is the charge on 1 mole of electrons. 1 mole of electrons, 1 electron has a charge of 1.6 times 10 power minus 19 coulombs multiplied by the Avogadro constant, which is L. So I'm going to try and figure out what L is. What do you get for L?
8.726 into 10 to the 22.
8.72?
6.
Into 10 to the power?
22.
22. But again, the number is really off. I mean, it should be somewhere close to 6.02. It's still close to it, but it's like really far away still. But I'll just check the marking scheme for this one. No, we made some mistake somewhere. We definitely did. The moles of copper, did we get the right moles of copper? Or moles of electron, 0.1603. Over there, the moles of copper atom are
moles of electrons are different. यहाँ पे हमारे पास ये तो
मोल्स हमने सही निकाले थे. कॉपर के मोल्स हमारे 0.08 ही आ रहे थे.
So you're getting 0.08, right? We got 0.1603, right? That's also fine. 16,200 coulombs is also. So where did we go wrong?
हमने electrons
On the mole
के
there.
No, just 1 second.
The mole.
सिंपली हम वो फॉर्मूला नहीं इस्तेमाल कर सकते कि number of atom is equal to moles into Avogadro number.
You go to. You can use that. I mean, there are many ways of solving this. I'm just saying, the first thing, I'm trying to figure out what the mistake is. We got points. I mean, there's nothing wrong with this, right? 0.1603 moles of electrons, right?
Yes, this is fine.
I think you multiplied by 2 electrons when there was no need.
No, we did multiply by 2 electrons, but that's the total number of electrons that we have, and that's the charge that's flowing through the circuit. So that is fine. Let me just quickly.
उन्होंने number of electrons भी निकाले हैं. We didn't do that.
No, they're two different methods, right? I mean, one is they're going with moles of electrons. That is 0.1603. Okay? And they're going with the charge. That's one way of doing that. The other one is going with electron. I mean, there are many different ways of doing this, but we're going with this method. We're using the ratio. We found the Avogadro constant using this. So if I just do this one more time, 16,200, and that's going to be divided
first
by.
method may be number of electrons.
Honey, we made a mistake. No, we made a mistake. No, we made a mistake over here. This is wrong. This number is wrong. I mean, everything was right. I think this calculation is wrong. 16,200 divided by 0.1603. I'm getting 101060.
Yeah, 101,060.5.
We did everything right, except this calculation is wrong. This is
101,060.5.
0.5, right? So that's the coulombs that we are getting. So this is the mistake. Tiki, you just correct that and you'll get the answer. 101060. 101060.5. Let's go try and find this out. You're going to divide that by 1.6 E minus 19. Okay, so we're now getting exactly 6.32 up till 3 significant figures into 10 power. 23. Okay, now it's fine. I said now the whole, so everything was fine. There was nothing wrong with it except for this calculation over here. Now I'm just going to explain this once more. Okay, because we had to figure out the Avogadro constant. So the assumption that the Faraday constant has this value is not going to be true, or you won't have this value because this value depends on the Avogadro's number. Okay, 1 mole of electrons, that's 6.02 times 10 power 23 multiplied by the charge on 1 electron, that's 1.6 into 10 power minus 19. That gives you the Faraday constant. So since we didn't have the Avogadro's number, we also didn't have the Faraday constant. So what I did was I experimentally calculated the Faraday constant. I knew that these are the moles of electrons and this is the charge that's flowing through the circuit. So 1 mole of electrons would be equal to this charge, and that is the Faraday constant. It's the charge on 1 mole of electrons, but that is the experimental value. So we found the experimental value of the Faraday constant, and we obviously knew the electron charge, so we were able to figure out what L was. Okay? Is that clear?
Yes, sir.
Yes.
Okay? I mean, the only confusion in this question was that you were not supposed to use the Faraday constant. You were not supposed to use this value. Okay? As the next one.
Sir, next one है इसका part D.
As I explained, why magnesium metal cannot be obtained by the electrolysis of dilute aqueous magnesium sulfate. Your answer should include data from the data booklet. So it's going to be, the reaction will be at cathode. So there's going to be magnesium ions, and there's going to be, what else would be present over here?
H plus.
Okay, water, or recent markets are also including H+1 as well. So we're going to go with H+1 as well. So this is the cathode. At cathode, electrons are, and the other side would be your anode. We're not interested in the anode, the cathode. So somebody has to gain electrons. So who gains electrons? The one that has the higher E0. Okay, that's the one that's going to gain electrons. So I just need to open the data booklet and find out. Okay, I've got Mg plus 2. Okay, there. So I've just this one. So I've got Mg, which is over here. And that's plus 2, that's gaining electrons. That is minus 2.38. I've got an equation for water gaining electrons, and that's minus 0.83. And I've got an equation for H+1 gaining electron as well, and that's 0.00. So the higher potential is, I mean, it's these two. These are much higher compared to this one. So that's it. That would be the explanation for this one, that Mg has a lower E0 compared to water and H+1. Okay, is that clear?
Yes, sir.
Sir, please here explain which one is a positive electrode about this concept, positive electrode.
इसके अंदर तो you have, what you have is you've got a cathode. I mean, in electrolysis, you've got a cathode and you have a anode. The cathode in electrolysis is always the negative one, because it's connected to the negative terminal of the battery, right?
Okay.
And the other one is your positive. So it's not a cell. You're not the one who's determining which one is negative, which one is positive. It's the battery that determines which one is the negative, which one is the positive. And the battery in electrolysis is sending electrons. So over here, they don't have a choice. The only thing that they can do is they can gain electrons. That's it. Okay. तो इसमें वो वाला issue नहीं आएगा, positive कौन सा, negative कौन सा, because the battery is the one that's deciding who's positive, who's negative. ठीक है.
And in case of, sir, in case of half cell, which one is a positive electron, which one is a negative? So give me this little bit idea, concept about this.
नहीं, वो different. Half cell is, if you have an electrochemical cell, then obviously the higher one is the positive, the lower one is the negative.
Okay, okay, sir. Higher one is a positive.
So next one, sir.
Sir, next question number.
That's why you mute हो गया, आप unmute कर लो.
Yes, sir. Question number 2 का part B.
That's a 2 part B. That's the reaction between hydroxide and this is suggests a practical method that would confirm. I'll this one, right? I'll explain a detailed method. They're probably not going to give you it's a 4-mark question still. So suggest a practical method that would confirm that the reaction is first order with respect to OH ions. Okay? So basically, you're trying to investigate a rate with respect to OH ions, right? And you want to figure out what the order is. They've already told you what the order is. It is first order. That is what you're looking for. That A should come out to be first order. I say your method should include the measurements, details of measurements that would be taken in order to calculate the rate of the reaction. So as a first thing, I'm going to keep all the other variables constant. That's the first thing. So keep all variables that are going to affect the rate of the reaction. I think somewhere over there they must have mentioned it. But anyways, if he hasn't mentioned it, keep all variables, other variables constant. Except for these two, because these are the two variables you're trying to find a relationship in. So you want to figure out, so what variables need to be kept constant? It has to be temperature, that has to be kept constant. Pressure is not an issue because pressure only affects gases. You don't have a gas over here. The total volume of the solution must be kept constant. And rate is dependent on two reactants. So you have to keep the other reactant as constant as well. So how do you keep the other reactant in constant? You're going to add it in large excess. So you're going to add CH3.
So if we don't mention that we're adding it in excess and just mention that हम लोग उसे concentration constant रख रहे हैं, तो mark करेगा?
But I think you should mention it that you're adding it in large excess to keep its concentration constant. Okay? They were doubtful because I mean they're going to ask you how to keep that constant. Okay? So you're going to add CH3Br in large excess. That's the first thing. Keep all other variables constant. Next thing is, how would you measure the rate of this reaction? Rate is, how do you measure rate? You measure any change with respect to
time.
With respect to time.
So you can simply half-lives calculate करके plot a graph.
हाँ, लेकिन पहले तो बताओगे, how do you measure the rate or what change would you plot with respect to time? You're going to make this graph. Change with respect to time, right?
Concentration.
ठीक है, so how do you measure the concentration? By measuring the pH of the solution, ठीक है? क्योंकि if you measure the pH, you can find the pOH as well. And using the inverse log, you can figure out the OH ion concentration. So that's how you're going to measure you're going to plot the concentration of OH ions. So one simple method is do one experiment and plot with respect to time the OH ion concentration. And the OH ion concentration would if it's a first order reaction, its half-life will be constant. Every time it's going to take the same time for the concentration to decrease by half. So that is one simple way of doing this. Okay, you can measure the half-life and the half-life needs to be kept constant. The other one is, what's the other one? The other one is you do several experiments and you measure the initial rate. The initial rate is the gradient of this graph. Okay, so what you do is you measure the initial rate. And then what you can do is you can do another experiment and double the concentration of OH ion. And if it's first order, the rate of the reaction would also double. So the gradient would be more steep. Okay, so you can do several experiments, repeat it, and just measure the gradient initially. And then compare it, make a table. So there are two ways of doing this. Okay, so that's, but the half-life method one is the simple one. They plot the graph with respect to time and just measure the half-life, that's it. Okay, is that clear?
सर ये हाफ लाइफ वाला आप एक दोबारा वो कर सकते हैं, एक्सप्लेन कर सकते हैं?
मैं करता हूँ एक सेकंड, अपनी उसके लिए
सर तो हाफ लाइफ के लिए हमें सिर्फ एक ही बार OH की कंसंट्रेशन देखनी पड़ेगी.
हाँ, लेकिन वो through across मतलब end तक you have to plot the concentration graph till the reaction stops. ठीक है?
फिर आपने क्या बताया था कि pH से concentration find करेंगे H की and फिर OH की find करेंगे.
हाँ, क्योंकि pH plus pOH is equal to 14, right?
Yeah.
So if you know pH, you can figure out pOH as well. And if you take anti-log,
तो concentration निकालने की जरूरत नहीं है, as in जब हम pH ही calculate कर रहे हैं.
हाँ, तो वो तरीका ढूंढना था ना, how do you measure the concentration of OH ions during the reaction?
Okay.
So
अच्छा,
every 2 seconds you just measure the pH. By measuring the pH, you can obviously indirectly measure the OH ion concentration. ठीक है. अच्छा, so I'll just quickly go through that. Okay, there are two ways to experimentally do this. One is you make one graph. You plot the concentration of a reactant with time and keep everything else constant by adding them in large excess and keeping the temperature constant. Everything is, all other variables are constant. So if the concentration decreases in a straight line, that means zero order. That means the reaction, even though the concentration is decreasing, nothing happens to the gradient of the graph or the speed of the graph. Nothing happens to it. So that's zero order. Here, order one is that if the reactant concentration decreases, the reaction slows down. It takes a longer and longer time to finish. In this case, the half-life is always constant. And then you have order two, which is if the concentration decreases. So what happens, it takes a much longer time. Order two means if the reaction concentration decreases by half, the reaction slows down by 1/4. Okay, so the reaction is slowing down at a much faster rate. So it's taking a longer and longer time. So the half-life is doubling every time. So this is one experiment that you could do. You plot the reactant concentration with respect to time. Okay, that's one way of finding the order. The other one is,
Sir,
yes.
By keeping large excess of, concentration of
other reactant.
Of the reactants, how it seems like it defies the order, the logic of,
you're saying why is that constant, right?
Yeah, why is that possible? Because you'll be thinking,
okay,
that,
so basically let's assume that X and Y are reacting, right?
Mm-hmm.
And I've got 0.1 moles of X and I've got let's say 10,000 moles of Y. Mm-hmm. And the reactant 1:1. So if you add anything in excess, its concentration for all practical purposes is constant. Why? Because if 0.1 moles of X react, right?
Mm-hmm.
And it's 1:1. So how much of Y would react? All the 0.1 moles of X will get used up, right?
Yeah.
And let's say the reaction finishes. So the concentration of X decreases to 0. What happens to the concentration of Y? 0.1 moles react with 0.1 moles. So you're left with how much? 999.9 moles, right?
Mm-hmm.
So what difference did it make on the concentration of Y? Hardly any difference, right?
Yes. Yeah.
So the idea is if you put anything in excess, so little of it is going to get used up that its concentration for all practical purposes would kind of remain constant.
Okay, thank you. It makes sense now. Thanks.
Next one. Where's the next one? This is the other method of finding experimentally the rate of the reaction is by just drawing a table. Not making the whole graph, just calculating the initial rate. Let's say you have a reaction and there's a gas being produced. You measure how quickly 5 cm³ of gas is produced. So initial rate would be 1/T. Like if you just have a stopwatch, you measure how quickly, let's say there's a color change happening, how quickly that color change happens. So rate would be proportional to 1/T. You're going to measure the rate and you're going to alter the concentration of the reactants. Let's say you double the concentration, you figure out what happens to the rate. If the rate also doubles, that means it's order 1. If it's quadrupling, that's order 2. Because that's the other way of doing this. Clear? Right? Is this clear?
Yes, sir.
Yes, sir.
Let's quickly see the working scheme as well. Use an excess of CSTBr, so they're very specific. Excess of CSTBr. We did this one. We did one experiment with known initial concentration OH and control the temperature and measure the time. Find OH ion concentration. Why we did it using, you can either titrate it, which is going to take a much longer time, because titration, there's OH ion, so you can titrate a sample by any acid and you'll figure out the concentration of OH ion, but the pH probe would be much quicker. And and you plot a graph of OH versus time and look for constant half-life. So that is what we did. The other version was that you could do several experiments using different initial concentrations. You can double the OH concentration, triple the OH concentration, and what you can measure is how is the rate changing every time. Is the rate doubling, or is it tripling or quadrupling? So based on that, you can figure out the order of the reaction as well. Okay. So what's the next question?
Sir, the next question is question number 3C2.
So 3C2. So over here you've got pure water. Remember that's pure water. Okay? But it's 50 degrees centigrade. So at 50 degrees centigrade, remember Kw. I mean your pH changes because the value of Kw changes. What was Kw? That you have water, and water ionizes very, very little. It produces two ions. One is H+1, the other one is OH ions. So you've got these two ions being produced. Now at room temperature, standard conditions, you have 1 into 10 to minus 7 mole per dm³ of H+1 and 1 into 10 to minus 7 mole per dm³ of OH ions. But remember, all equilibrium constants, their value changes with temperature. At higher temperature, more water molecules are going to ionize. So the concentration of H+1 would be taken as X, and the concentration of OH ions would also be taken as X, because both would be produced in equal quantity. So what is Kw? Kw is the equilibrium constant for this reaction. So it's H+1 concentration multiplied by OH ion concentration divided by the reactant concentration. The reactant is water, that's in large excess, so that is taken as a constant. So you don't write the concentration of water. Now the value is known. It's 6 point. Sorry, the pH is known. So the pH is. I said we had to figure out. So we know what X is actually. The pH is known. So pH is minus log of H+1, and that value is 6.64, right? So what is H+1 concentration according to that? That's going to be 10 raised to the power minus 6.64. So basically
2.291 into 10 power minus 7.
So basically we know what X is, right? So it's 10 power minus 6.64. And OH ion will also have exactly the same concentration because it is pure water. So the amount of the two ions would be exactly the same. So it's just 10 raised to the power minus 6.64, and that's going to be squared. So what is Kw now?
Sir, 5.248 into 10 power minus 14.
5.248.
Yes, into 10 power minus 14.
Minus 14. So just remember, just a quick recap, the dissociation of water increases at higher temperatures. So you'll have more H+1 and more OH ions, but they're going to be produced in exactly the same quantity. So we figured this out. What's the next question?
The next is question.
Okay, question.
KW के साथ हमारे पास जो KPC होता है, उसमें भी we do the same thing where we actually divide ये reactants over the products. Again, sir, उसमें मैंने I read the topic.
KPC is totally different. Like it is KC as well. It is products over reactants.
What I'm trying to say is that KPC we don't really know whether to divide the reactants over the products or the products.
In that case, you have a partition, right? In that case, just let's say you've got oil and you've got water, right? So there's a substance X dissolved in water, and there's a substance X, the same substance dissolved in oil as well. And there's an equilibrium between on the partition. So in that case, the reaction is X is in water, and it's traveling into X oil, and X oil is getting converted back into X water, right? So in this case, you don't really know which one is the product, which one is the reactant. So the question So in that case, this could be the other way around as well. So in that case, you don't know which one is the product, which one is the reactant. So Skander, what you do is it is written in the question. Like if they ask for the KPC between oil and water, so oil would be the numerator, that would be your product. So it's going to be the concentration of X in oil.
So ये question, I have this question 2020 में October November 4th. तो अगर फिर बाद में आपको टाइम है तो we can review that.
जी ये एंड पे कर लेते हैं, इसके बाद इस पेपर के बाद पे वो कर लेते हैं, ठीक है? नहीं और कौन सा क्वेश्चन है इस पेपर का? दिस वन
सर इसमें फिर क्वेश्चन नंबर 5 का पार्ट सी.
अच्छा 5 part C. अच्छा this one is describe the observations, if any, that you would make when a few drops of NaOH are added to be, nothing would happen in this case. Why? Because because barium chloride is soluble. It's all about solubility. Barium chloride is soluble. So the solution will have barium chloride ions, right? If you add NaOH to it, NaOH is also soluble. So the solution will have Na ions and OH ions. Now the ions would randomly mix and no two ions will form something that is insoluble, because any combination of the ions, there is no precipitation. Barium with OH ions, that's barium hydroxide, that is soluble. Na with Cl, that is NaCl, that is also soluble. So the ions would just remain mixed up in the solution. Nothing would happen, no reaction, right? Okay, is this clear?
Yes, sir.
But in the other one, there is going to be a reaction. If you add barium chloride, which is soluble, barium ions and Cl ions, and you mix H2SO4 into it, which will have H+1 and SO4 minus 2 ions. So in this case, there's obviously going to be a reaction. What insoluble compound would be formed?
Barium sulfate.
Okay, so there's going to be a precipitate of barium sulfate. HCl would remain part of the solution, so you would see a white precipitate. And probably no misty fumes, because you need to have concentrated acid. But I'm not sure. We would have to check the market scheme if they've, because the H+1 and Cl ions can also combine together and they would form HCl gas. But that usually happens when the acid is very, very concentrated. So I'll check if that is an observation as well. Copy. You know the 5C?
Yes, sir.
No change in that one, and then white for white precipitate. That's it. Okay, so no marks for HCl forming. You just remember for in inorganic chemistry, HCl, hydrogen chloride, white steamy fumes of HCl would be formed if the acid is very, very concentrated. So what comes the next one?
Sir, hydrochloric acid के steamy fumes होंगे?
नहीं होंगे ना, वही मैं कह रहा हूँ कि if you're just adding dilute acid, like if you remember group 17 inorganic, group 17 inorganic was when you used concentrated H2SO4. Then at the moment, the H+1 and Cl-1 would be so dilute and there would be so many water molecules, okay, there would be very little chance of them forming fumes of HCl. HCl fumes are not formed in a dilute solution.
Oh, okay, sir.
Okay, but again, if the acid is very concentrated, there's a lot of H+1 ions, then there's a lot of chance of H+1 and Cl ions combining to form HCl gas, which is white.
Can you explain first wala? NaOH and BaCl wala?
But you mix them together, right? They're soluble. When something is soluble, it dissociates. So the ions, they just mix in water, right? Barium ions, Cl ions. NaOH is added Na+1 and OH ions. So all these ions are now mixed in water. So they're just floating around in water, right? So the point is, will any of the ions combine to form something new? They're not.
NaCl form over.
No, but NaCl is soluble, right? So if NaCl is soluble, because NaCl is very soluble, so it's going to dissociate or mix in the water again. It would form dissociated sodium ions and Cl ions back again. Clear?
Same for BaOH.
But they're not going to get back together because they're very soluble.
So yeah.
So but end में what happens is that the ions are just mixed in solution. That's it. Nothing new happens. So what's the next? Yes.
Sir, question number 7 का part A. So मुझे पूछना था कि 2 repeat units को किस तरह draw करते हैं? What does that mean?
2 repeat units is, remember these two would combine together to form 1 repeat unit. Yeah, then the whole thing would repeat. So you've got the H over here and the Cl over here, HCl would be formed, so they're going to combine. So you'll have C double bond O, and on the other side you're going to have this carbon and this N would link up. So this would be NH, and you will have just one second. You'll have another benzene, and the whole thing would repeat on the other side. Okay, now you have to, and there's going to be C double bond over here. I said now this is 1 repeat unit. Okay, that's 1 repeat unit. Then there's going to be this molecule coming after this. So you would have to repeat this entire thing. Okay, so remember in condensation polymers, 2 monomers combine to form 1 repeat unit because they're 2 different monomers.
So basically 4 monomers only, 2 repeat units.
वो देख भी लेते हैं if they meant something. This is which question was this?
So question number 7 part A.
It's the same thing. That's how you interpret this.
Sir, इसके बाद question number 8 का part C.
I say 8 gives the structural formula of B. I have this. So what is the reaction where the carbon chain length increases?
CN.
You had 2 CN.
So
you're basically adding CN. So this is NaCN ethanolic. This is the reaction of nucleophilic substitution. SN2 becomes a primary halogenoalkane. So that's SN2, right? So NaCN
और कुछ नहीं हो सकता क्योंकि like carbon chain increase हो रही है.
मैं दिखा देता हूँ. Let me just the carbon chain length is increasing. You have a halogenoalkane. You're going to a carboxylic acid, right? In 2 steps. So I'll just show you. Okay, if you look at this chart, you've got a halogenoalkane over here, and you want to make a carboxylic acid, which is over here. So the 2-step reaction, there are many different paths that you could follow, but that's going to take a lot longer. The only direct path is you replace the halogen with CN, you end up with a nitrile, and then the nitrile gets hydrolyzed with acid and or alkali, and it turns into a carboxylic acid. So in 2 steps from halogenoalkane to carboxylic acid, that's the only path that you have. Okay, because that's the only path. There's no other path. You can't increase the carbon chain length. You have to make a nitrile first. So this is the only path that is available to you. So yeah, any other question?
Sir, last question number 9 का part A.
So 9 part A, state the number of delocalized electrons in one this molecule, this one. Number of delocalized electrons. So you're saying the nitrogen atom in the 6-membered ring has 1 electron in an unhybridized p orbital. This electron becomes delocalized, becomes part of a single delocalized system of electrons. So he's already told you that the nitrogen atom in the 6-membered ring has 1 electron. So this nitrogen atom is contributing 1 electron to the delocalized system. becoming part of a single delocalized system of electrons. This delocalized system also includes electrons from the carbon atom. So each carbon atom is also contributing 1 electron each, right? So that is 6 electrons delocalized over here. So he's saying the delocalized system also includes the electrons from the carbon atoms in the 6-membered ring. So that's so those are yours. So that's a total of 6 electrons. The 2 electrons in the pi bond of the C double bond O. So the electrons over here are also part of the delocalized electrons.
So
So
benzene ring का carbon bonded to C double bond O है, उसका फिर electron खत्म नहीं हो जाता since it's bonded to something.
it's making 3 bonds. ये वाला जो carbon है ना, this one, it's making 3 bonds, right? So the 4th electron, I mean, this is what benzene looks like. Every, I mean, there's a nitrogen atom over here, but every carbon is making 3 bonds, right?
सिर्फ वो ऊपर हाइड्रोजन भी तो होते हैं उनके ऊपर.
वो मैंने बना दिया ना, there's a hydrogen, but each one has 1 p orbital, right? Each carbon atom has 1 p orbital. Well, it's making 3 bonds, right? So if it's making 3 bonds, the 4th electron of carbon is delocalized.
जो hydrogen usually connected होता है, वो उसको हटा के हमने ये वाला लगाया.
हाँ, मतलब यहाँ पे there's a serial bond O over here, right? So there is no hydrogen over here.
Right.
मतलब अगर तो if it's making a benzene electron cloud, that means the 4th electron is not doing anything. It's just delocalized. That's why you have a ring. Okay, so this carbon is making 3 bonds, not 4 bonds, because the 4th electron is delocalized. I said again, what he's saying is that the pi bond over here is also, how many electrons do you have in the pi bond? I think that's 2 electrons, right? Like if you have a double bond, there's a sigma bond, that's 2 electrons, and there's a pi bond, that's 2 electrons. So he's saying the 2 electrons in the pi bond, so that is also part of it. And the 2 electrons in the lone pair on the oxygen atom. So even these lone pairs over here. So now you can count how many electrons you got. You got 6 over here and 4, that's 10.
सर बेंजीन वाले N का एक मतलब एक फ्री इलेक्ट्रॉन है.
उससे कहा हुआ मैंने लिखा हुआ इसमें basically question कोई नहीं है. Everything is written over here exactly. The nitrogen atom in the 6-membered ring has 1 electron, and this electron becomes delocalized. So basically, nitrogen has 1 electron in an unhybridized p orbital, and this electron becomes delocalized. So 1 electron. But everything is written over here. You just have to just sum them up. Okay. So any other question?
Sir, ये part B 1 and 2 only.
Yeah.
नहीं, B का 1 and 2.
I said draw the structural formula of E in the box. So you've got a benzoic acid, and it's turning into an amide. So how does it turn into an amide? Remember, this is an amide. So how does anything turn into an amide? Amides are formed. Amides are formed when you have an acyl chloride. To form an amide, you always need an acyl chloride.
See, acyl chloride और aryl chloride में क्या फर्क है?
There's no difference except for aryl chloride has a benzene in it. Aryl is instead of a carbon chain, you have a benzene. As a baki, you've got an NH2, so what happens is that the H and the Cl will get knocked out and it will form an amide. So you would have to turn it into an acyl chloride. How do you do that? That's PCl3 plus heat, or SOCl2 plus heat. So this molecule turns into an acyl chloride, and then you can obviously react it with, and the HCl will get knocked out. ऐसा कोई और है?
So I have questions from October number 21, paper 41.
एक second.
Sir, partition वाला ये 20 वाला
नहीं कौन सा चल वो पहले कर लेते फिर वो वाला कर लेते हैं और कौन सा 20 कौन सा
So 21,
20
21 and paper
नहीं, winter.
41.
winter 21 summer 21
Winter is 21, October, November 21.
और 41
Yes, sir.
एक से पहले एक खोल ले वो भी बता दो इब्रार वो कौन सा
सिर्फ वो अक्टूबर नवंबर 24
October 24 2 वही की क्वेश्चन है ना वो कर लेते पहले just 1 second साइड में एक सेकंड रुकना पड़ेगा एक क्वेश्चन कर ले अच्छा कौन सा पार्टीशन कोएफिशिएंट which question
So इसमें क्वेश्चन नंबर ये क्वेश्चन नंबर 5 party
5 it's 5 part E this one नहीं this is about stability constant
जी सर ये भी करा दे ये एक क्वेश्चन सिर्फ ये एक्सप्रेशन बना के how
अच्छा
do we-
stability remember stability constant is the Ligand exchange in an aqueous solution so he's talking about the K stability of this thing so it's going to be Hg aqueous ion अच्छा what is the charge on Hg over here I think that would be +2 because Cn is -1 अच्छा Cn is -1 so total charge is -2 so Hg must be +2 अच्छा so it's Hg aqueous or you can write it as Hg with 6 water molecules ठीक है and the whole thing will have a charge of 2+ and 4 CNIons come in and there's going to be a Ligand exchange. So the aqueous solution, the ligand of water gets replaced by CNIons and it ends up forming Hg with Cn, 4 of them, and the total charge would be -2 and 6 water molecules are getting replaced. The reason it's pointless to write water is because firstly, you don't know what the water complex is. I just made this up. I don't know because we have never studied the water complex of Hg. We haven't studied aqueous complex of Hg. So I'm not really confident that this is 6. But the expression doesn't really matter because if you write products over reactants, water is in excess because everything is an aqueous solution. So water is in excess. So its concentration is a constant. So you don't write it in the expression. So it's going to be HgCO. That's your product.
सर इसमें हम ये नहीं करते because I've been through this topic इसमें ये होता है कि if we want to find a K stab of a solution तो वो ionize होके ions बनाता है I mean a product ionizes to form ions जैसे question था कि K stab of magnesium fluoride
नहीं I'll just K stability of magnesium chloride you're mixing two things up. This is not solubility product. K stability is that you have any aqueous solution, but the starting point is an aqueous solution. Let's say you have a copper with 6 water molecules, any aqueous solution, and you add some random ligand to it. Let's say you add NH3 to it, 6 of them, and all the water molecules they get replaced by NH3. And let's assume all of them get replaced by NH3. I mean, this is 2+, this is 2+, and so 6 water molecules get replaced. So K stability is your equilibrium constant of a ligand exchange reaction for an aqueous solution or in an aqueous solution. So it's going to be products over reactants. The water is not going to be written in the expression because in aqueous solution, water is in large excess. So you don't write it in the expression. So if I were to write the K stability expression for this one, I'll have the starting point would be Hg in water, right? Or Hg aqueous. I'll add the CN9 ligands. The CN9 ligands will come in and they will replace the water ligands and it will form Hg with CN4, right? and all the water molecules are going to get knocked out. I'm going to write products over reactants, which is going to give me this. Water is not going to be written in the expression because water is in large excess. ठीक है, is that clear?
सर लेकिन मैग्नीशियम फ्लोराइड का फॉर एग्जांपल अगर आप करें तो उसका हमारे पास ऑपोजिट आता है.
नहीं है, magnesium chloride is not an example because it's not a ligand exchange reaction. What is the, I didn't get you. What is the ligand exchange that's happening in magnesium chloride?
I mean, just saying कि अगर हमने सिर्फ K tab of a particular substance, so let's suppose we want to find K tab of magnesium fluoride.
No, but that is not a complex. Okay, K stability only applies to a reaction where there's a ligand exchange that's happening. मतलब वो randomly किसी compound के ऊपर नहीं apply कर सकता. It has to be a ligand exchange where one of the ligands, especially the water one, I mean the starting point is an aqueous solution, and you add some other ligand, and a ligand exchange happens. Okay, so it's K stability is the equilibrium constant for this specific reaction. Okay, so you can't just apply it randomly to any substance or any other reaction. ठीक है
जी ठीक है ओके.
अच्छा बस यही था इसमें.
और वो केसी वाला था वो इसके कंपोनेंट 4-3 में क्वेश्चन नंबर 4.
Is that Hg aqueous with a charge of 2 plus 2 or?
Yeah. Sorry. So yes, it's plus 2.
Plus 2, yeah.
That's fine. The reason I won't go with He with 6 water molecules is because I don't know what type of complex it forms. We haven't studied it. It's not in your books as well. So I'll instead of writing it as Hg with water complex, I'm just going to write it as Hg plus 2 aqueous.
Mm-hmm.
I mean that so that because we're not sure what the complex is, so we'll just generalize that. Achha, 4-3. Just one second quickly. Simon, एक second रुक जाओ. बल्कि ये वाला खुल ही था. Just one. अच्छा इसमें which question?
Question number 4.
Achha, this one. This is partition coefficient, right? So water and octane 1-ol form 2 layers, right? So let's make those layers. You've got 2 layers. Not really sure which one is the water layer, so I'm just going to make this water, and this is. Achha, this one is octane 1-ol. This one is octane 1.
हमारे पास इथेनेमाइड है, octane 1 और वाटर अलग है.
नहीं, water and octane form 2 layers. ठीक है. Ethanamide is the substance that is mixing in the 2 layers. Do you get the point?
Oh, अच्छा जी ठीक है.
So I'll just call ethanamide as the solute. So there's going to be some of ethanamide in water, and there's going to be some of ethanamide in octane 1-ol, right? So he's saying 1 gram of ethanamide is added to 50 cm cube of water. So the volume of water is 50 cm cube, and he ended up adding how much? Exactly 1 gram, right? In the water layer. And it's then shaken with 50 cm cube of octane 1-ol. So you're shaking it with 50 cm cube of. So what will happen is that the ethanamide 1 gram, some of it, let's say X grams, will dissolve in the other layer. So X grams go into the other layer. Sorry. So X grams go into the other layer. And they've also, it is found that the water layer contains 0.935 grams of ethanamide. So you started off with 1 gram. So what mass do you have now? That's 0.935 grams, right? So how much of it actually went in the other layer? That's going to be
0.65.
0.065 or 65?
0.65.
Okay, so I even have the mass. So he's saying calculate the partition coefficient of ethanamide in water and so water would be your numerator and octanol would be your denominator. So you'll find KPC.
Why do we keep water as a numerator?
It's just okay, the way you write the expression is you don't always keep the water as the numerator. The one that comes first, that's your numerator. The one that comes later, that's your denominator.
I mean, in the statement. I mean,
but the problem is you don't know okay, how is the reaction written. Like ethanamide in water, is it written like this, that there's an equilibrium between X in water and X in octane 1-ol? Or maybe it's the other way around. So you don't know what the expression or how the expression is written, right? Okay, it's going to be products over reactants, or is this the product and that's your reactant? So that's the confusion. So what you do is that the whatever is written first, that's your numerator. The other one is your denominator. Okay. So it's going to be 0.935 over 50 water. And the other one is 0.065 divided by 50. So you'll find your KPC. So okay?
Ji sir, thank you.
So Saim, what question?
So question number 2.
W21 QB41, right?
Yes, sir.
So question number 2 is you have to write pura?
Sir,
कर लेते हैं वो K का actually पूछा भी था, so I'll just do this. K is what is the expression for this? It's Cl CH2 3 times, and then there is COH. It's going to ionize, and it would produce. नहीं समझ आया क्या कह रहे हो?
I'm saying just a random question. If we have like a buffer solution, and the question says that what happens if you add like a few drops of acid or base, and how like does the buffer solution behave? So in the mark scheme, like in the question asks us to write down a whole equation. So what if I just write like the equilibrium equation and then explain that in terms of the equilibrium shift? Would that work?
It will work for the H plus one, but not for the OH minus one, because you have to show the OH ions. I'll just take it. I mean, this is your expression in this one. Okay, you Cl as a CH2 thrice. So you okay, right? What's the mathematical relationship? That's what is it? It's K is sorry. pK is minus log of
K.
Calculate H plus 1. So the pH is given 4. So if the pH is given,
so 10 raised to power minus 4 करके direct कर सकते हैं ये?
the way लेकिन show the working, ठीक है? और make sure you always show the working. Okay. It's minus log of H plus 1, your pH is 4, so it's going to be 10 power minus 4, right? H plus 1 is going to be 10 power minus 4. As I calculate the ratio of HCl dissolved versus this. Okay, so how do you calculate the ratio? Okay, the amount of HCl dissolved. Remember, both of them have the same pH. HCl is a strong acid, first one. So if you have a strong acid, the strong acid, what happens is there is no reversible reaction. It ionizes completely. So HCl is going to ionize and it's going to produce H plus 1 and Cl minus 1 ions. Now he's saying that both solutions have the same pH. So if HCl has a pH of 4, that means the concentration of H plus 1 is going to be 10 power minus 4, right? And the concentration of HCl would also be 10 raised power minus 4 mole per dm cube. So what you figured out is you figured out the concentration of HCl, right? Now the next thing is you want to figure out the concentration of this particular weak acid. So when you have a weak acid, इसको मैं generalize करके लिख रहा हूं, I'm just writing it as RCO-1. So now when you have a weak acid does not completely ionize. A weak acid is described by its strength is described by its K expression, which is products over reactants. So it's going to be RCO-1 concentration into H+1 concentration divided by the weak acid concentration, which is RCOOH. And or the simpler way is these two ions will have exactly the same concentration. So you can write it as, the same expression can be written as K is equal to H plus squared divided by the concentration of the acid. Both ions have equal concentration. So you just have to simplify this. The value of K is given, which is 4.52, but that's pKa. So the value of K would be 10 raised per minus 4.52, right?
Yeah.
The H+1 is also known. They've told you that the pH is 4. So that's 10 power minus 4, right? And that's getting squared as well. And you can figure out the acid concentration using this expression. Saimi, clear?
Yes, sir. Thank you, sir.
So,
acid concentration कैसे calculate करेंगे?
क्या?
Acid concentration कैसे आएगी हमारे पास? ये RCOH.
हाँ, वो आ जाएगी ना, क्योंकि these two have the same concentration, right? So say question is already given you that the pH of the solution of both solutions is 4. So you know H+1, and the pK value is also given for the acid. So you know what K is, which is pK was 4.52. So K would be 10 power minus 4.52. Similarly, H+1 was given as pH was given as 4. So your H+1 concentration would be 10 raised per minus 4. So you'll find the acid concentration using the same formula.
लेकिन हमने इसमें स्क्वायर क्यों लिया है H+ पे?
नहीं, क्योंकि ये वाला आयन और ये वाला they're going to be produced in exactly the same concentration, right?
Oh, okay, sir.
तो वो बजाय इसके कि you
acid concentration की समझ नहीं आ रही ऐसे कैलकुलेट हो
बस इसको उधर ले जाओ, उसको उधर ले आओ.
अच्छा, हम एसिड की कंसंट्रेशन ढूंढ रहे हैं. अच्छा, ठीक है. और ये हमारे पास ये 10 raised to minus 4.52 जो है, ये pK है.
हाँ, उससे दिया था. They gave you the pK value that was given. That is 4.52.
और pK is equal to minus log of K.
हाँ, मतलब वो उसके log. So it's going to be 10 raised to minus 4.52. K would be 10 raised to minus 4.52.
अच्छा, तो why is pK being equated to ये reactants over ये products?
Ka is H+1 squared divided by the acid concentration.
हाँ, ठीक है.
ये मतलब for any weak acid, every weak acid is described by its K expression.
अच्छा, ओ ठीक है, ओके.
ठीक है, क्योंकि one of them, हाँ.
सर मैं पूछ रही हूँ तो उसका रेशियो किस चीज के तो दोनों की सेम है, तो फिर दोनों की किस चीज को डिवाइड, कौन सी वैल्यूज को डिवाइड करेंगे आपस से?
किनका दोनों सेम है? नहीं, जैसे मैं फिर से see you had HCl, right? अच्छा, these two are not linked. ये जो top one is completely different, the bottom one is completely different. The first thing was that they asked for was if you find the concentration of HCl based on the information that is given. Now HCl was a strong acid, so strong acid fully ionizes. They told us that the pH of this acid was 4, right? So if the pH was 4, the concentration of H+1 was 10 raised to minus 4. And since it's a strong acid fully ionizes. So if the H+1 concentration is 10 per minus 4, the HCl concentration would also be 10 raised to minus 4. ठीक है? ये पहला part clear है कि we were able to figure out the HCl concentration based on the fact that it's a strong acid. Second जो part है ना, the denominator, ठीक है? That has nothing to do with the first one. They're completely two different solutions. Remember this, okay? This solution and the hydrochloric acid solution, one of them is solution Y, the other one is solution Z. They're not interlinked. They're completely different solutions. The only thing common between them is that they both have pH which is 4. Okay? So I'm going to work with this other solution, which is a weak acid. Now, when you have a weak acid, it ionizes, and a weak acid is always described by its Ka value. So K is products over reactants, and if you simplify it for a weak acid, it basically becomes H+1 squared divided by the acid concentration. Like this expression turns into, I mean, the generalized expression is this one. ठीक है, ये भी clear है?
जी sir.
So in the denominator, what he was asking for was the acid concentration. So we were looking for this acid concentration. We wanted to, ठीक है, ये जो sorry, okay, एक second. So basically we wanted the acid concentration, right? So we had the H+1 concentration because they told us that the pH was 4. The pH of this solution was 4, and the pH of this other solution was also 4. So I knew that the H+1 concentration was 10 raised to the minus 4. So I put it in the expression, and that would become 10 raised to the minus 4, and that's going to become squared. The K value was given for this acid. pK value was given, that was 4.52. So I used that value and put it in the expression. So the K value would be 10 raised to the minus 4.52. Okay? And all I need to do is I need to find the acid concentration, which is going to be what? It's going to be 10 raised to the minus 4 squared, and it's going to be divided by. ठीक है, is that clear?
जी सर, तो फिर इन दो वैल्यूज को फिर HCl के कंसंट्रेशन से माइनस करेंगे,
माइनस से डिवाइड करेंगे.
ओ हाँ सॉरी.
ठीक है, so the final expression would be, we have to calculate the ratio. So the HCl concentration is 10 raised to the minus 4, and you're going to divide it by the other acid concentration, which is this one, 10 raised to the minus 4 squared divided by 10 raised to the minus 4.52. ठीक है, so you're going to divide both. अच्छा, और कौन सा?
So question number 6, part C and D.
एक सेकंड.
तो उससे पहले ये क्वेश्चन नंबर 3 पार्ट सी से गो थ्रू करवा दे. मेरा आंसर मार्किंग स्कीम से डिफरेंट आ रहा था, हालांकि क्वेश्चन ये वाला क्वेश्चन इजी है.
नहीं, एक सेकंड, मैं छोड़ देख रहा था. अब बताओ, हाँ क्या कह रहे थे?
से क्वेश्चन 3 का पार्ट सी पहले करवा दें, उसके बाद क्वेश्चन नंबर 6 पार्ट सी एंड डी.
अच्छा, क्वेश्चन नंबर 3 क्या सी पार्ट?
यस सर. अब मेरा आंसर डिफरेंट आ रहा था मार्किंग स्कीम से.
कितना डिफरेंट आ रहा था?
तो काफी डिफरेंट आया था.
अच्छा, so कर लेते हैं. So we've got oxygen exists as O2 molecules. Use the data in this question to calculate a value for the bond energy of the O double bond O. Show all your working. So अच्छा, इसके लिए ना इसके अंदर ट्रिक ये थी कि you had to O double bond O. ठीक है, you have to figure that out. So I'm going to use this one first. I've got half O2 gas plus 2 electrons, and that's going to form O2 minus 1 gas, right? So ये हो गया. And this has a value of plus 951. ठीक है, remember I have to make the O double bond O the subject of the equation. So there's the electron affinity of oxygen given. So if I have an oxygen atom, gaseous, that will gain 2 electrons, and it will form. So I'm talking about these two. Electron affinity is an oxygen atom gaining electrons, right? So I've got an oxygen atom, first electron affinity and second electron affinity. So if the oxygen atom gains 2 electrons, that's going to be minus 142 plus that's 844, right? Okay. So we are at this point now. Now the only step missing is this one. Okay, what am I doing over here? The 2 electrons are not doing anything. So it's basically oxygen gas molecule turning into an oxygen atom. So what I'm doing is I'm breaking the oxygen double bond oxygen, half of it. Okay, I've got a half O2 molecule and I'm breaking it and I'm turning it into an oxygen gas molecule. So this is the unknown. Clear?
Yes, sir.
So you had to make a Hess cycle. You had to. I mean, it was slightly tricky because you had to. I mean, you weren't supposed to use the whole thing. You just had to use. I mean, this was actually very tricky because they gave you a lot of irrelevant data just to confuse you. So now the cycle is complete. So one path is equal to the other path. So that's your one path. That's your other path. So that means 951 is basically equal to half into X. Okay, so oxygen double bond oxygen bond energy is X. And then it's minus 142 plus 844. Okay, so one path is equal to the other path. So we just solve this. Okay.
Sir, buffer solution के questions कुछ करवा दें और electrophoresis की revision.
ठीक है. So एक कोई और question है क्या?
Yes, sir. Question number 6, part C and D.
So ये बस एक आखिरी करना फिर करते हैं. 6, 1 second. As a 6 part C, use value suitable. Use suitable E0 values from data booklet to predict whether iodide ions can reduce CO2 plus to CO2 plus. It's I2 plus 2 electrons, and it's 2I minus 1. And this is, I think, 0.54 volts. And you got copper 2 plus 1 electron. And iska zara batao ki what values do you have? This is, I think, this is 0.15. Not really sure.
0.15.
So this one is 0.15. So higher potential would gain electrons and lower potential would lose electrons. So what is he asking? Whether iodide ions can reduce copper 2 plus. So वो कह रहा था कि you want the copper 2 plus to get reduced. And that is not going to happen. Why? Because the
Lower
copper
E value.
potential reaction will go the other way around, not this way. So what you're just going to write is that it's not going to happen. Why? Because the I2, I minus 1, sorry, a second. I said now that is definitely not going to happen because the I2, I minus 1 electrode has a higher E0 compared to the copper 2 plus copper 1 plus electrode. ठीक है, मैं वो लिखना है. Clear?
Yes, sir. Thank you.
उसका D भी था, D था. Say an excess of copper sodium iodide is added to copper 2 sulfate. Copper 1 iodide forms as a precipitate. After precipitation, copper 1 ions concentration is much lower than 1 mole per dm cubed. Use this information in your answer to explain how the relevant electrode potentials change, and hence I minus 1 can reduce copper 2 plus ion. So it's the same reaction. Okay? Right now, nothing is happening. I mean, right now, no reaction is happening. Because you want this to be going in the forward direction. That's not going to happen. So, लेकिन वो कह रहा है कि नहीं, okay, use this information to explain how and why I minus 1 can reduce copper 2 plus. So now he's saying that due to the change in concentration, the I minus 1 can reduce copper 2 plus. And this reaction goes backwards. Now the only way that is possible is the lower potential is the one that loses electrons and the higher potential is the one that gains electrons. But at the moment, that is not going to happen because this is not the lower potential and this is not the higher potential. So how does changing concentration affect that? Okay, the copper 2 plus concentration is much lower than 1 mole per dm cube.
तो सर मतलब कि copper 1 ion large amount में होगा.
हाँ.
Equilibrium shifts
to the left, right? Like if copper 2 plus concentration is much lower,
नहीं कॉपर +1 की नहीं लो है,
कौन सी?
कॉपर +1 की लो है तो
Ah, sorry,
फॉरवर्ड नहीं जाएगा।
after precipitation, copper +1 is much lower. So if copper +1 is much lower, this one. So the equilibrium would shift forward. If it shifts forward, what will happen to the potential? It's going to
be higher.
It's going to be higher. Okay, it's going to be a lot higher.
So
So
why is it going to be higher? Can you repeat, right?
अच्छा एक तो ये याद रखना कि whenever let's say any reaction ये वाला कर लेते हैं. अच्छा, firstly, all potentials are calculated under standard conditions. So this is calculated under standard conditions. So 1 mole per dm cube, 1 mole per dm cube. Whenever the potential shifts to the right, according to Lee-Shackler principle, okay, you decrease the concentration of copper 1 plus, you increase the concentration of copper 2 plus. The new potential would be higher than the previous one. And whenever the potential shifts to the left, the new potential is going to be lower than it's going to be more negative. Okay? The reason for that is okay, these two ions are in equilibrium. This is what the electrode looks like. And there's a platinum electrode that's added, right? If the equilibrium shifts to the left, okay, let's assume that the equilibrium shifts to the left side, right? So if the equilibrium shifts to the left side, so kya hoga? It's going to produce a lot of electrons, right? So on the electrode, a lot of electrons are going to get produced. And your electrode potential would become more negative. It's going to be lower. Okay, clear?
Yes, sir.
But a simple idea, if the equilibrium shifts to the left, a lot of, whatever reaction is happening, it's going to produce a lot of electrons, a lot of extra electrons, and those electrons would accumulate on the electrode, and your electrode would become more negative. So your new potential would be less than the old potential. Okay? Or vice versa, if the equilibrium shifts to the right side, so your electrons are going to get consumed. The copper 2 plus ions is going to consume a lot of electrons. So your electrode would have very few electrons now because all the electrons would be getting consumed by copper 2 plus, and it will become more positive. Okay, तो ये बस याद रखना कि simple rule कि if more electrons are produced, the electrode would become more negative. Vice versa, if the reaction shifts in the forward direction and electrons start getting consumed, then the reaction, the electrode potential would become more positive. Okay. So, but this question में ये कि if the copper 1 plus concentration decreases, the equilibrium shifts to the right and the potential would increase. So maybe let's say the potential increases to 6.60 volts. Let's assume that it increases to 0.60. What happens then? Now this is the higher potential and that is the lower potential. So that would lose electrons and this would gain electrons. Is that clear?
Yes.
Yes, sir.
Sir,
Okay. Hanji.
For a protein molecule, how do we describe its primary, secondary, and tertiary structures?
No, that's not in your course. Okay, don't worry about that. Okay, primary, secondary, just basic peptides and tripeptides. That's in your course. Like if you're given two amino acids, you're supposed to draw a peptide bond between them. That's it. No further detail about primary or secondary or tertiary structures is any longer in your course. So I'll just do the buffer solution questions. 1 second.
Sir, electrophoresis करा सकते हैं, please.
हाँ, दोनों कर लेते हैं इससे.
Okay, sir.
वो बहुत आसान है. इलेक्ट्रोफोरेसिस जो है वो बहुत बच्चों वाला है. नहीं, वो कर लेते हैं उसके क्वेश्चन में दिखा.
वो इलेक्ट्रोफोरेसिस का फिर एक दफा डायग्राम बना के दिखा देंगे, जैसे वो क्वेश्चन में कहता है कि डायग्राम ड्रॉ करें, लेकिन
हाँ, वो दोनों कर लेते हैं. ठीक है. अच्छा, 1 second. कहाँ पे है? अच्छा, this is buffer solution. ठीक है. ये pH of the buffer. Sif will only do some buffer solution questions. So to explain what is meant by the term buffer solution, so it's a solution which resists a change in pH when a small amount of acid or alkali is added to it. ठीक है.
ये
अच्छा,
इसका
वो कह रहे
दूसरा वाला क्वेश्चन भी समझा देगा.
कौन सा?
लॉरी ब्रॉन्स्टेड वाला.
ये वाला ना हाँ
Yes.
अब वो कह रहे हैं कि there's a buffer अच्छा remember a buffer solution is formed from a मैं असल में HA use करता हूँ, I'll just use HA. It's made from a weak acid and its conjugate base. ये बल्कि कोई actual acid use कर लेते हैं. Let's say I have ethanoic acid and that is in equilibrium with so let's say I have this reaction. The buffer solution requires a weak acid and its conjugate base. You want a solution just kind of there's a weak acid. The weak acid will behave as an acid, obviously, because it's going to produce H+1 ions. And the solution should also have CO-1 ions. Now, these ions are added from the salt. Because naturally, the amount of ions would be very less because it's a weak acid. A weak acid does not ionize, so it's not going to produce a lot of these ions. So you add extra ions by adding a salt. Okay, so you need these two things. So what are the reactions? The buffer solution would resist a change in pH. So if you add H+1, let's say you start adding H+1 to the solution, who's going to neutralize it? This or this?
Sir, this.
Okay, the conjugate base is going to neutralize it.
Conjugate base, yeah.
So the CH3CO-1 is going to consume all the extra H+1s that are added, and it would neutralize them, and it will form ethanoic acid, right? So vice versa. If you add OH ions to it, the buffer solution is going to neutralize it. So out of the two, who's going to neutralize it? The acid is going to neutralize it. It's going to release a proton, and that proton is going to react with the OH ions, and it will neutralize it. So the CH3 COH is going to neutralize the OH ions, and so it will turn into CH3CO-1, and the H+1 that would be released would neutralize the OH ion to form water. Okay, those are the two reactions that you're going to get. Okay. Or in simple words, it's this equilibrium that is shifting forward or backwards. That if you add too many H+1 ions, the equilibrium shifts backwards. If the H+1 decrease because of the addition of OH ions, the equilibrium would shift forward. Okay, but you have to make this equation up for the OH ions. Okay.
तो सर इसकी wording क्या लिखेंगे?
कोई wording नहीं, बस ये दो equations are, that's it. Explain how. अच्छा, wording बस एक line. Acid added. That's it. If acid added, this happens. Finish.
Sir, 4 marks मिल जाएंगे इसमें?
मिल जाने चाहिए, देख लेते हैं. If it's or if base added, that's it. क्योंकि equations, remember chemistry में the equations are self-explanatory. If you write an equation, you don't have to write a lot of. But you can go on explaining this. Like if an acid is added, the conjugate base accepts H+1, then you write this equation. If a base is added, but most likely, कौन सा paper है? This one is 1 second. मिल जाएंगे. कौन सा क्वेश्चन था? एक सेकेंड. तो ये जो चीजें
इक्विलिब्रियम के हिसाब से बताया हुआ है.
अच्छा, इक्विलिब्रियम के हिसाब से बताया हुआ है.
सर हाइड्रोनियम का भी मेंशन किया हुआ है.
हाँ,
इसमें तो हाइड्रोनियम का भी मेंशन किया हुआ है.
हाँ, लेकिन वो इम्पोर्टेंट नहीं है. वो नहीं, both of them are acceptable. ठीक है. I'm just saying addition of acid, it moves to the how an equilibrium point was mentioned किया हुआ है. H+1 combines with Z-1 and forms HC. So this is where we wrote an equation. ठीक है. और यहाँ पे भी H+1 combined more over here we wrote an equation. Addition of a base. तो ये तो दो थी. equilibrium के साथ उन्होंने कहा था link कर दो, so try linking this up with the equilibrium in this particular case. ये लेकिन थोड़ा पुराना क्वेश्चन, recent वाले जो है ना उसके अंदर बस ये लिखा हुआ है, ये दो लिखा होता है, that's it, and they just ask you what the two reactions are. But you can obviously this is 13, so recent ones when it's more straightforward. लेकिन mention कर दो, मैंने ज़्यादा detail देने में there's no problem with giving more detail. That's as a next one. We've got propanoic acid. It's a weak acid. Calculate the pH of propanoic acids. That could be done. ठीक है, you.
सर ये फॉर्मूला मुझे बड़ा कंफ्यूजन लगता है.
कौन सा?
पीके वाला
फॉर्मूला मुझे
फॉर्मूला
बड़ा कंफ्यूजन लगता है. Yes, sir. I don't know how to-
मैं सिंपल वो कर देता हूँ. फॉर्मूला ये है. Two formulas are ठीक है. There's just two formulas for weak acids. You've got a weak acid. All weak acids can be represented by this thing. Okay, they release an H+1 and there is some other extra ion. Okay, that's it. K is product over reactant, right? So it's H+1 concentration into A-1 concentration over the acid concentration. In simple words, you can just write it as H+1 squared.
Sir, इसमें कोई question है related to mass spectrometry?
नहीं, इसमें तो नहीं होगा. वो भी बाद में करते हैं, पहले ये तो कर लेना.
हाँ सर, वो बाद में करा दो.
अच्छा खैर ये K वाला K का ना, this is the expression that you're going to use for a weak acid only. ठीक है, if you have weak acid only, that's it. That's the formula. Okay, you would be either given. I mean, it's going to be a very simple question. ठीक है, not that difficult. You just have to know two things and you'll find the third thing. That's it.
तो जो ऊपर वैल्यूज गिवन है उसमें हम बस सिंपल मोल ओवर कंसंट्रेशन कर दें.
हाँ, तो बस ये है ना कि they're asking for the pH of a weak acid, right? If it's a weak acid only question, just use this formula. K is equal to H+1 squared. ठीक है, even this formula has many different versions. ठीक है, you don't just this version would be fine. Put the K value there. ठीक है, that's what 1.34 into 10 to the minus 5.
इसको into 0.5 का अंडर रूट ले लें और फिर
अच्छा इसका 0.5 है, so you'll find H+1, right? And you can find pH then. Clear?
सर pH का वो वाला minus log into H plus वो क्या था फॉर्मूला इसका?
हाँ, pH is minus log of H+1 concentration, right?
Okay, sir.
So that's it. The other formula is for a buffer. Okay, what happens in the buffer is, in the buffer you have an acid, ठीक है, weak acid. So you've got a weak acid, plus you mix a salt of the weak acid. मतलब ये वाला जो ion है ना, you mix I mean you add conjugate base, ठीक है. Usually it's coming from a salt, ठीक है. So it's the same expression. Everything is the same except for in a buffer. ये जो पिछला नहीं था buffer, that was a buffer, right? So in the buffer you have this particular ion is produced from a salt, or you add extra conjugate base to it. So the formula, I mean the same formula changes. It changes because these two ions no longer have the same concentration. So now for a buffer, your K expression would be H+1 concentration. अच्छा, कहाँ से A-1 आ रहा है? That's coming from the salt, ठीक है? So that's going to be the salt concentration or the conjugate base concentration divided by the weak acid concentration.
फिर मतलब buffer solution के अंदर you would be given one extra value, right?
हाँ, या तो directly given होगी और sometimes it's indirectly given. यानी जैसा अभी the next question.
सही है.
So इसके अंदर you need an extra value. You need like if you want to find pH, you need K. You also need the salt concentration. You also need the acid concentration.
Salt
extra added होगा ना कि if you want to make it a buffer solution, you have to increase this ion in the solution. So that is increased. We had this solution, right? We had ethanoic acid and we had ethanoate ions, right? So like in a normal solution, the amount of ethanoate ions would be very less. So you add a salt to increase the ethanoate ions. So that is added extra by adding a salt. ठीक है, तो बस इसको पहले रिकैप कर लें कि 2 formulas. Weak acid only, there's only weak acid. Question is only about weak acid. So it's just K is equal to H plus 1 squared divided by the acid. Okay, just put those 2 values, you'll find the third value. Second formula, if it's a buffer solution, then these 2 ions will not have the same concentration, so you can't write it as H plus 1 squared. So instead, it's going to be K would be H plus 1 into the salt concentration, whatever this ion is, divided by the acid concentration. Okay. So the next part over here is about a buffer solution. Okay, this one is about a buffer solution. So he's saying buffer solution F was prepared. Achha, now this is an indirect question because the buffer solution.
Sir, buffer solution का formula है हमारे पास ना कि pH plus log of salt over acid.
वो वही है ना, मतलब वो इसी को अगर log में ले लो ना, it's the same thing.
हाँ तो
मतलब वो जो फॉर्मूला नहीं है, तो तुम जो फॉर्मूले की बात कर रहे हो ना कि if you take the log on both sides, it's going to be pK is equal to pH plus negative log ले लो ना, तो it's going to be pK plus pH plus log of salt over acid, right? Minus log of salt over acid, which is the same thing. ठीक है, you can take the log at the end, you don't have to take the log. I told you that there are different versions of the same formula, they all do the same thing. Clear है?
सर आप HNMR और मास स्पेक्ट्रोस्कोपी का एक क्लैश कोर्स दे सकते हैं?
वो कल ही करेंगे, अभी तो नहीं करेंगे वो, उसकी मैं वीडियो भेज दूंगा।
अभी इलेक्ट्रोफोरेसिस करा दो सर जल्दी से।
हाँ वो मैं कर लूँ, ये तो कर लेना पहले। अच्छा, you've got buffer solution F, ठीक है, buffer solution F is propanoic acid, sodium hydroxide। अच्छा, अब इस केस में ना there's the buffer solution is going to be prepared first, क्योंकि what is a buffer solution? It's going to be a solution of the carboxylic acid plus its conjugate base or the salt, ठीक है। तो इसके अंदर क्या हो रहा है? What is happening is NaOH is reacting with propanoic acid. So if you react NaOH with propanoic acid, so what happens is you get
sodium propanoid और फिर आपका water बनेगा।
Water, ठीक है। अच्छा, moles are given. There's 0.03 moles of NaOH, and there is ये कितने moles है? 100 into 0.5. 0.05 ना, you check कर लो, 0.05 100 into 0.5 divided by 1000, ठीक है, so that's 0.05. So which one is in excess? That's NaOH will completely react 1:1, right? Iske 0.02 moles would be left at the end of the reaction, right? So 0.03 will react with 0.03 to produce 0.03 of this. Is that clear?
Yep.
Yes, sir.
So now he's asking for
and 0.03 of water as well.
But I'm not interested in the water. It will produce 0.03 moles of water, but we're not interested in the water. I say yeah again. Now it's a buffer because you've got the conjugate base or the salt, and you've got the weak acid as well. So these two combined are forming a buffer. So I'll just use the formula of K, which is what H plus 1 concentration into the salt concentration, which is 0.03, right? Divided by the acid concentration, which is 0.02. I don't even need to calculate the concentration because for concentration, I would have to divide by volume. Since it's numerator over denominator, the volume part would get cancelled out. The K value, we already have that. That's 1.34 into 10⁻⁵. So you can figure this out. K 3/2. Okay, so H plus 1 would be 2/3 of this. Okay, is that clear?
Yes.
So your buffer is actually the sodium ethanoate?
Your buffer is a combination of, it's a mixture of a weak acid plus the salt. दोनों चीजें चाहिए ना, to form a buffer you need a weak acid, ethanoic acid, plus you also need the conjugate base as well.
So तो acid का 0.2 मोल कैसे आया है?
इस केस में क्योंकि initially कितना moles था? It was 0.05 moles, right? And the NaOH that was added was 0.03 moles. So it's 1:1. So 0.03 will react with 0.03 of this. So 0.05 में से 0.03 गए तो पीछे कितना रहेगा? That's going to be 0.02, right?
सर तो इसके अंदर जो थर्ड पार्ट है जिसके कॉन्सेंट्रेशन वो मांग रहे हैं हम मोल्स के हिसाब से ही लिख देंगे
नहीं वो तो उधर you have to find concentration because the solution has a volume of 100 cm3. So over there you would have to find the concentration, which is 0.03 divided by 100 cm3 is 0.1 dm3, right? ये बल्कि गलत लिख दिया. That's for this one. ठीक है. And the other one would be for this, it's going to be 0.02 divided by 0.1.
0.1.
ठीक है. 100 cm3 is 0.1 dm3. Is that clear?
Yes, sir.
एक और कर लेते हैं buffer solution, especially with the graphs. Even not with the graph, it's अच्छा ये for example, the show you're working is but that's moles. अच्छा ये भी this one. Let's look at this one. अच्छा this one is a buffer solution. ठीक है, it's a solution of that's made up of these two compounds. The salts contain these two ions. So which one is the acid? Which one is the conjugate base? Okay, I've got H2PO4 -1 and I've got HPO4 -2.
HPO4 is the conjugate base.
हाँ ठीक है. जो acid होता है ना उसके पास it has more H+1 ions. ठीक है. So basically it's this happening. H2PO4 -1 is going to be acting as the acid. It will ionize in the same way. It's going to release an H+1 and it will produce what? HPO4 -2 ion.
HPO4 -2 is the conjugate acid. Conjugate base, sorry.
Conjugate base, ठीक है. तो इस तरह भी आ जाता है कि I mean the acid does not have a specific formula. They could give you any formula. ठीक है. Just remember okay, the one with the more hydrogen ions is the one that's going to act as the acid. It's going to release H+1 and it's going to form the other ion. So the question is, this question is slightly
to show how this buffer reacts.
हाँ वो तो वही है कि what happens if H+1 is added? The H+1 will react with the conjugate base, which is HPO4.
H2PO4 बनाएगा.
-2, it's going to react with it and it's going to form H2. PO4 -1. Vice versa, if you add OH ions. So who will the OH ions react with? The H2PO4. H2PO4 is going to release H+1 ions and neutralize the OH ions to water, and it will turn into HPO4 -2.
सही है.
ठीक है. अच्छा, the other part is slightly trickier. I mean, you're going to use the same formula, which is what K is equal to H+1 concentration into
conjugate base over
conjugate base or salt concentration. ये क्या क्वेश्चन है?
तो ये हम pH of buffer solution ही कैलकुलेट करने जा रहे हैं. And this is what this.
नहीं, अभी we'll start calculating using this. The first part is, so now this one is slightly tricky. They gave you two informations. They told you that a buffer solution containing equal concentrations of the two sodium phosphate salts, yani equal concentration of this and this, has a pH of 7.2. And then he says, calculate the pH of a pharmaceutical preparation containing 0.002 mole per dm cube of Na2HPO4. I mean, this is going to have which ion? This is this one. I mean, Na2HPO4 contains HPO4 -2 ions. So this one is 0.002 mole per dm cube, right? And this other one, which is NaH2PO4, so it contains the H2PO4 ions. That's 0.005 mole per dm cube. So that's 0.005 mole per dm cube. So I'm going to put those in the expression, and I'm going to try and figure out what K is. So it's going to be conjugate base. It's going to be 0.002 divided by double
अच्छा,
zero
नहीं, square नहीं.
square नहीं होगा इसमें. It's a buffer, ठीक है. So it's going to be 0.002 divided by 0.005. Is this clear?
pH के फॉर्मूला से आप H plus की वैल्यू निकाल लो.
हाँ, लेकिन अब now there's one problem. They didn't give you the Ka value. So how would you find H plus 1? So they
They
didn't.
gave the pH.
They have
नहीं.
given the pH, तो आपको minus log वाला फॉर्मूला
नहीं,
निकाल
नहीं.
के H plus.
They gave you a pH of some other solution. We have to find the question with tricky part here. They gave you the pH of some other solution, not this one. We're trying to find the pH of this solution. Okay, so our purpose of the calculation was to find pH. To find pH, we would need Ka value. So this previous information about some other random solution is going to be used to find the Ka value. K का क्या formula? It's H plus 1 into the conjugate base concentration or the salt concentration divided by the acid concentration, right? They said that the two solutions, the two sodium phosphate salts have equal concentrations. So if they have equal concentrations, so this thing gets cancelled. Okay, so that gets cancelled out. So that means Ka is going to have the same value as the H plus 1 concentration. And remember this property as well. Okay, in a buffer solution, if the salt concentration and the acid concentration are equal, so they get cancelled out in the expression, and your Ka would become equal to your H plus 1 concentration, which over here is 10 raised power minus 7.2. Okay. So
6.31 into 10 to the power minus 8.
लेकिन अब what you're going to do is you're going to use, because K is a constant, right? So you're going to use this in your solution, which is 10 raised power minus 7.2 is equal to H plus 1 into
Yes, sir.
over 0.005. Okay, so remember this solution over here had nothing to do with the solution whose pH they were asking you to calculate. So but using the first solution, you were able to figure out what Ka value is, and then you're going to use that Ka value in this other solution to find the pH.
K is constant, though it doesn't change with the change of concentration.
K is an equilibrium constant. It only changes with one thing, and what is that one thing?
Temperature.
Okay, ये सारे, whether it's KSP, KPC, all of them, even rate constant, they all change with temperature only. Okay.
Yes, sir.
So बस अच्छा electrophoresis का मैं जल्दी से I'll just do
सर जब H plus की फिर वैल्यू निकल आएगी, जब H plus की वैल्यू निकल आएगी फिर फॉर्मूला लगा लें
माइनस लॉग, ठीक है. हाँ, pH आ जाएगा, ठीक है. लेकिन बस वो ये समरी है इसकी. कहाँ गई समरी हमारी? Summary is, if you have a weak acid only, meaning there is no buffer, there's just a weak acid. ठीक है. So it's just going to be K is equal to H plus 1 squared divided by acid. ठीक है. You'll just use that formula. It's going to be a simple question, and you'll just put in the values. You'll find the pH or whatever they're looking for. ठीक है.
Sir, एक second, can I see the question? I need to take a screenshot.
ये था.
Yes, sir. इसका नहीं question दिखा दो. Okay, sir. Thank you.
नहीं, question भी बस यही था बस. So next, इसका बस कर लेते हैं electrophoresis. दो चार चीजें उसमें बस. उसकी एक वीडियो मैंने भेजी थी electrophoresis की. 1 second. 9701. अच्छा, let's say.
सर जो मास स्पेक्ट्रोमेट्री और जो एनएमआर वाले जो लेक्चर्स थे आपके, उसके लिए एक लेक्चर तो आपने रिकॉर्ड नहीं किया था ना, जो बाकी दो हैं, इज इट इनफ या शुड बी आल्सो लुक इन द फर्स्ट वन?
मैं भेज देता हूँ, मुझे पता है कौन सा रिकॉर्ड किया था, लेकिन जस्ट सेंड इट. ठीक है.
आई थिंक बस पहला वाला ही रिकॉर्ड नहीं हुआ था, बाकी वाले हो गए थे.
अच्छा, नहीं, उसमें बहुत सी वीडियोस हैं उसमें, तो मैं भेज देता हूँ. ठीक है.
ओके, थैंक यू.
अच्छा, so first thing, does repeat करें. Electrophoresis is that you have a filter paper or a chromatogram which is soaked in a buffer solution. Maybe they're going to ask you for a diagram as well. The diagram is simple. Okay, this thing is present in a glass slide, just some chromatography, it's just you just put the chromatogram in a glass slide, and there is a solution over here. Okay, so this thing is mixed. This thing is present in the solution, or दो wires होती हैं. This side is connected to the positive terminal of the battery, right? And this other side is connected to the negative terminal of the battery. So like electrolysis, if you have a positive ion, which side will it travel to?
To the negative side?
It's going to travel to the negative side, and vice versa. If you have a negative ion, it's going to travel to the positive side. And if the molecule has no charge, then it's going to stay right in the middle. I mean, that's the whole concept. So whatever you put, whatever mixture you apply at the center, it's going to travel, and two factors determine how quickly it travels. The direction, what factors are? The direction is dependent.
Their mass and charge.
Hold करो जरा, खुल जाए.
Okay, sir.
हाँ ठीक है, mass मैं मुझे बता दूँ mass, क्योंकि the heavier the molecule, the longer it's going to take, the slower it's going to travel. And the other one is charge. And two things depend on charge. Okay, one thing is the direction of the travel, which we just discussed. And just 1 second. So one thing is the direction of where the particle travels, right? And the other thing is, if you have greater charge, then obviously it's going to travel faster. If something has a charge of +3, it will travel or get attracted to one side with a lot more force. So just 1 second. Okay. Just search the electron. ISO. That's a question. So this one. What clear the first thing? Saro clear?
कौन सी वाली बात, sir?
वही कि how quickly the particle travels.
Depends on the charge and mass.
It depends on the charge and it depends on the mass. Basically, it depends on the its direction depends on the charge, whether it's plus or minus. And the distance depends on this ratio, which is distance is directly proportional to the charge and inversely proportional to the mass. Because the heavier the particle, the lesser distance it's going to cover. And the other one is the greater the charge, the more distance it will travel. Okay, so that's the first thing. And then you have the next thing, which is the amino acid. You're going to place an amino acid over here. What happens to the amino acid? So the amino acid, he says that it exists as a zwitterine, the isoelectric point of valine and lysine. अच्छा ये given होगा अब, ठीक है? Valine is this amino acid. It's
Sir, आप isoelectric point दोबारा वो
explain करता हूँ. मैं explain करता हूँ isoelectric point. अच्छा, this is, you could Google कर ले, what is valine? What is the R group? But data booklet में
होता है. हाँ जी होता है.
अब तो given होगा ना question में, वैसे कह रहा हूँ कि for the question.
एक second sir.
एक second मैं कह रहा हूँ. So valine has, it's got 2 branches of CH3s. So this is valine. The only thing to remember is about the isoelectric point, because that is going to decide whether it's going to be a negative ion or it's going to be a positive ion. So in simple words, isoelectric point जो है ना, remember this side is the acid side and this side is the base. So the NH2 can accept an H+1 and the acid over here can lose an H+1 ion. So he's saying that the isoelectric point of valine is 6. Okay, what that means is at pH 6, if it's at pH 6, according to valine's perspective, pH 6, think of it as a neutral solution. Okay, at pH 6, it's going to be a zwitterine. Okay, that's the isoelectric point. Okay, at what point is it a zwitterine? So at pH 6, it's going to be a zwitterine. What that means is that the acid over here would lose the H+1 ion and it will form a minus ion, and the base on the other side is going to accept an H+1 ion and it will become a positive ion. So overall it will have no charge. This is a zwitterine and it has no charge. Okay, so isoelectric point is the point at which the molecule forms a zwitterine. You clear? The amino acid forms a zwitterine. Is this clear?
जी sir.
Acha, फिर next one. So what happens if it's not the isoelectric point? Acha, above the isoelectric point, for valine, it will be as if the solution is basic. And below the isoelectric point for valine, because the isoelectric point of valine is pH 6. Every amino acid has a different isoelectric point. Now below the isoelectric point, specifically for valine, it will feel as if the solution is too acidic. Okay? So let's go back. Okay, let's go back to making to valine. Okay, you've got COH. So let's say the pH is 8. A pH 8 is a lot higher than the isoelectric point of valine. So that means, okay, valine would feel as if the solution is too basic. So if the solution is too basic, which one of the two groups would react? The carboxylic acid group would react, right?
Yeah.
सर एक मिनट दोबारा से रिपीट करेंगे, आपकी आवाज कट गई थी.
ठीक है
नहीं, मैं वो कह रहा हूँ कि pH 8 जो है ना वो for valine that is just too basic. ठीक है, is that clear?
Yeah. Yes.
So in basic conditions, which group would react? The basic part will not react. The acidic part will react, right?
Yes.
So in basic conditions, the acid part will react. It will form a -1 ion. But in basic conditions, the basic part of the amino acid is not going to react. Is that clear? So at pH 8, valine would look like this. And it will instead be a negative ion. Is that clear?
Yes.
Yeah.
So vice versa, if there had been pH 4, if they had been talking about pH 4. Now pH 4 is lower than the isoelectric point. So that means for valine, the solution is too acidic now. Okay, so if the solution is too acidic, and let's make valine again. So if the solution is too acidic, then in an acidic solution, the acid part is not going to react. The basic part will react. And the basic part will end up reacting with or accepting an H+1 and it will become an H3+1. So now it's going to be a positive ion. Clear?
Yes, sir.
So all you need to know is that at the isoelectric point, the carboxylic acid would behave as an acid and the base would also behave as a base. It will lose H+1 and that will gain H+1. This will form a negative ion and that will form a positive ion. That means it's a zwitterine. That means it has no overall charge. So that is what happens. The ion is neutral. Overall, it's neutral at the isoelectric point. Basic and if you make the solution too basic, more basic than the isoelectric point, then the amino acid, the acid part will react, not the basic part. And if you make the solution acidic compared to the isoelectric point, then in an acidic solution, the acid part will not react, the basic part will react. So depending on what happens, it will either have no charge or it will have a negative charge or it will have a positive charge. Is this point clear?
Yes.
सर एक सवाल है
हाँ
सोल्यूशन का तो पता चल गया ना, उसने आपको बता दिया कि हमारे पास जो वैल्यू है इसकी आइसोइलेक्ट्रिक पॉइंट की वो सपोज 6 है, तो उसके ऊपर सारा बेसिक होगा, उससे नीचे सारा एसिडिक होगा। लेकिन वो तो सोल्यूशन की बात होगी, आयन की जब वो बात करेगा हाउ टू चेक इफ एन आयन इज एसिडिक और बेसिक, तो फिर वो किस तरह बताएंगे?
नहीं, we're not talking about the ion. मतलब the ion is both, ठीक है?
And all amino acids या सिर्फ valine?
नहीं, all amino acids have an acid part and they also have a basic part, ठीक है?
Okay, sir. So
My
how do we
point is they have both things, ठीक है? My point is if I add an amino acid into an acidic solution, तो acidic solution में the acid part will not be able to react, right? Is that clear?
Okay, sir. Yes, sir.
मैं इधर क्लियर करके बताता हूँ कि वो लाइसिन की
मुझे
भी
वो
बात
समझ आ गई कि acid solution के अंदर acid part will not react, base part will, and vice versa. लेकिन my question is how can we determine if the ion itself, like the protein amino acid itself, वो acidic है या basic है?
नहीं, वो तो दोनों है, it's amphoteric, it can do both things, ठीक है? अच्छा, CH2 4 times and then there is NH2. अच्छा, this one, let's try this one. अच्छा, the point is कि it can do both things, right? लेकिन if I make the solution acidic, so that means there's a lot of H plus ions, right? So in the presence, I mean, that means the solution is acidic. So in the presence of a lot of H plus ions, the acid will not be able to lose H plus ions because acidic and the acid is not going to react. Is that clear?
Yes.
So ये मैं explain कर रहा हूँ कि if you make the solution too acidic, the acid part will stop reacting. Vice versa, if I make the solution too basic का क्या मतलब है कि the solution has a lot of OH ions now. So if the solution has a lot of OH ions, then the basic part will not be able to react because the NH2 will not be able to accept H plus ions because there is no H plus ions. But the acid part will start reacting.
सर इन्होंने जो कहा है डाइपेप्टाइड, हमने वैलिन और लाइसिन दोनों
नहीं,
का
वो तो एक अलग क्वेश्चन है ना, वो तो उसमें मैं आता हूँ
सही।
पहले तो एक्सप्लेन कर लें कि अच्छा, अब लाइसिन हैज, अब मुझे क्या बताओ कि लाइसिन हैज एन आइसोइलेक्ट्रिक पॉइंट एट 9.8, ठीक है? दिस इज लाइसिन, द वन दैट आई हैव ड्रॉन. मुझे बताओ व्हाट वुड लाइसिन लुक लाइक एट 9.8?
इसके दोनों के आयन्स बन जाएंगे NH3+ and COO-.
ठीक है, so this would become NH3+1 and that would become CO-1, ठीक है? Clear है? So at 9.8, हाँ?
आपकी आवाज टूट रही, could you repeat this part again, all of it?
I'm just saying the isoelectric point of lysine is 9.8, right? I just said what would lysine look like at 9.8? So at 9.8, it's going to look like a zwitterine. This part will lose H plus 1, that part would gain H plus 1. Clear?
Okay, sir.
Achha, फिर same question. Let's वापस कर देते हैं. COH. Achha, second question. What would lysine look like at pH 7?
So एक साइड पे NH3 और दूसरी साइड पे COO negative.
नहीं, पहले बताओ कि the isoelectric point. The isoelectric point is 9.8. pH 7 would be for lysine. It would be too acidic. The environment would be too acidic.
So the base will react. So base का होगा plus.
ठीक है. So in an acidic environment, the base is the one that's going to react. So only this part would accept H plus 1. That part will not be able to lose H plus 1. Okay. This is what I'm explaining, that the zwitterine will be formed at the isoelectric point. Below the isoelectric point, the environment would be too acidic for the amino acid, and above the isoelectric point, the environment would be too basic for the amino acid. Okay. Is that part clear?
Yes.
Sir, here is only one part of NH2 is react, not the other part in the acidic conditions.
Acidic, the acid part will not be able to react.
No, sir. Here is NH3, is another NH2, second amino.
Sorry, I didn't see that. Well, remember this, there's another NH2 as well. So in this case, both of them, I didn't see that. Sorry. Both of them. हाँ ये बाकी सारों को clear है ये? There was another NH2 as well. Is this clear?
Yes, sir.
अच्छा बाकी है कि the so that's one important thing. ठीक है? What would the amino acid look like under different pH conditions? अब यहाँ पे the question is a mixture of dipeptide, valine, lysine, and its two constituent amino acids, valine and lysine, was analyzed by electrophoresis using a buffer at pH 6. So first thing, pH 6, isoelectric point of valine is 6. This is going to be a zwitterine. A zwitterine would remain exactly in the middle. So valine ka jo spot hoga na, that would remain exactly in the middle because at pH 6, in a buffer that has a pH of 6, valine will form a zwitterine. Is that clear?
सर लेकिन ये zwitterine में हमारे पास दो पॉजिटिव चार्जेस है और सिर्फ एक नेगेटिव चार्ज है, तो ओवरऑल पॉजिटिव चार्ज नहीं होगा इसमें? Because we have two positive.
No. Valine is this one. Valine is this one.
अच्छा, sorry. नहीं, अगर वो केस हो तो फॉर एग्जांपल वो भी तो हो सकता है.
हाँ, उस केस में होगा फिर.
तो वो तो zwitterine ही है लेकिन फिर चार्ज भी है. And zwitterines तो overall.
उस केस में there's going to be an overall charge because both of them would be having a
it's
negative.
Still called a zwitterine, right?
But that will not be called as zwitterine because the zwitterine has regions of positive and negative charges, but it's not going to have an overall charge.
All right.
ठीक है. तो उस केस में you're going to call it as zwitterine if it has no overall charge. So वो होगा कि there will be two positives and one negative, but there would be an overall charge, so you won't be able to call it as zwitterine. चलो इसका कर लेते हैं. This is valine, right? pH 6 के ऊपर the isoelectric point is also pH 6. So that means it's going to be in the form of a zwitterine. Zwitterine has a positive charge and a negative charge, so it's not going to have an overall charge. So valine would be right in the center. It's neither going to be attracted to the positive side, it's not going to be attracted to the negative side. ठीक है? Is this clear? At pH 6, valine's isoelectric point is also 6. Valine stays in the middle. Is this clear?
जी sir.
अच्छा अगला वाला lysine पे आ जाते हैं. So lysine's isoelectric point is 9.8. He's talking about doing this at pH 6. So the solution is too acidic for lysine, right? So if it's too acidic, क्योंकि lower than 9.8 है ना, lower pH जो होता है that's acidic.
अच्छा हाँ ठीक है.
मतलब it would have been a zwitterine at 9.8. But now the pH is 6, so that means the solution is too acidic. हमने वो 7 का किया था ना. He's talking about doing the reaction at pH 6. So that means it's too acidic now. So if it is too acidic, so the basic part will react, both of them. So lysine will have a positive charge. It will have a +2 charge. So if lysine has a +2 charge, where will it get attracted to? It's going to get attracted to the negative side, right?
Sir, because of the +2 charge, तो वो ज़्यादा negative side के पास होगा ना, like more towards the
और ज़्यादा distance भी ज़्यादा होगा, right?
So do we have to be very exact and obvious या फिर किस तरह करें?
Distance इससे ज़्यादा होगा. Distance is proportional to charge over mass, right? So the charge is greater. +2. If you have a greater charge, it's going to cover a longer distance. ठीक है?
When do we look at mass? Mass के हिसाब से distance.
तो इसमें करेंगे. इसमें over here you don't have an issue because valine is not moving, so वो तो relative comparison होगा ना. When you have a relative comparison, then you look at mass.
So yeah.
But इधर तो issue ही कोई नहीं है because one of them is not even moving, so it doesn't really matter where you put lysine at the moment. ठीक है? Is that clear?
जी sir.
अच्छा, then draw and label 3 spots of the electrophoresis paper to indicate the likely position of each of these 3 species after electrophoresis. And they've given us the isoelectric point of valine and lysine. They're talking about pH 6.
वो third वाला spot किसका होगा?
वो dipeptide.
अच्छा हाँ, वो नहीं बनाया.
So there's a dipeptide as well. Just one second. Let me, a mix of dipeptide, this, and 2 constituent amino acids are analyzed, label 3 spots. indicate the likely position. So lysine is over here. Without any doubt, lysine is over here.
सर
So
जो
we
डाइपेप्टाइड होगा वो मिडिल में होगा इन दोनों के.
वो भी draw करते हैं. 1 second. अच्छा, I'm going to draw the dipeptide first. अच्छा, dipeptide is very. अच्छा, पहले तो देख सेकंड. Dipeptide will be. Valine was. The first thing, what is the dipeptide? It's valine. Valine comes first. ठीक है. So CH3 and CH3. The carboxylic acid side reacts with the amine side from the other side. ठीक है. So, and that's your lysine. That's CH2. 4 times, and you got NH2. And you got a carboxylic acid group on this side, and you got an amine group on this side. So that's it. Did I draw this correctly? This is valine, but in the middle I've joined them, the 2 amino acids. So that looks fine. I don't think there's any issue with that. I said now this one. They didn't tell you the problem with this question is they didn't tell you what is happening to what is the isoelectric point of this molecule over here. Okay, that's not mentioned. So
but separately तो बताया हुआ ना, valine और lysine का separately बताया हुआ है.
But valine and lysine are different molecules, and this is another molecule that is produced after the reaction. वो relative strengths of acids का पता था कि relative strengths of acids में I mean, remember, like if I have ethanoic acid, right? If I do a reaction and I make CCl3, so the strength of the 2 acids is not comparable. There's a difference. Like if there's a reaction and a different group gets attached to it, then the strength of the acid would vary, right? Because of the electron donating effect or the electron withdrawing effect. Okay? So you can't really compare the two. Is that point clear?
ठीक है sir.
I said, but since the pH is 6, so they didn't give us the isoelectric point. So I'm just going to assume that the solution is too acidic. So I'm just going to assume that because they didn't give the isoelectric point of this third molecule, but they told us that whatever is happening, the electrophoresis is happening at pH 6. So this one, I'm just going to assume that it's an acidic medium, pH 6, and in an acidic medium, the base will react. So it's going to be NH3 plus 1, or can't be NH3. This is going to be NH3 plus 1, right? So your two bases will accept H plus 1 ions, right? And it's going to form plus 2. So this one would also travel to the negative side, but it's going to travel a smaller distance. Why? Because it's a bigger molecule.
Mass ज़्यादा.
Mass ज़्यादा. ठीक है. तो ये लेकिन ये question clear है सारा. एक इसमें question में there's one flaw with this question, which is they didn't give the isoelectric point of this new molecule.
ये valine lysine कहाँ पे होगा बीच में?
हाँ, क्योंकि ये जो बड़ा molecule है, this is bigger in size, right? So if it's bigger in size, it will travel a smaller distance.
What if, sir, we assume that the solution for the dipeptide is too basic?
Let's say let's just quickly see if they accepted both answers or not.
Sir, एक सवाल.
हाँ.
You were talking about CCl2 और उसका ethanoic acid का वो आप ऐड कर रहे थे. उसके बाद आपकी आवाज छूट गई थी. कुछ रिपीट के फिर वो जो valine
मैं सिर्फ एक्सप्लेन कर रहा था कि एक सेकंड मैं इसकी MS बोल रहा हूं.
वो मतलब आयरन गेट वो डाइपेप्टाइड की पोजीशन किस तरह किधर होगी मुझे नहीं समझ रही सर. डाइपेप्टाइड में CO पे नेगेटिव चार्ज क्यों नहीं है?
रुक रहा है एक सेकंड. अच्छा क्या था पहला? What's the first question? कि अच्छा वो मैं कह रहा था. I was saying कि somebody said कि भाई valine has an isoelectric point of 6 and lysine has an isoelectric point of 9.8. Now this dipeptide is formed when valine and lysine react. I was just making the point that this new molecule, this is a new molecule now. I mean, this big molecule is a different molecule compared to वो जो valine था और and you had lysine, right? So this one is, although it's made from valine and lysine, but it's a different molecule. Its isoelectric point is not going to be linked with the isoelectric point of the individual monomers. Is that point clear?
Yes.
ठीक है, क्योंकि वो चीज ही कोई और है, तो उसका और
तो ये पॉजिटिव चार्जेस
क्या
अपने की पॉजिटिव चार्जेस किस बेसिस पे लगाया?
अच्छा, उसके बारे में, उसके पीछे मैंने वो तुक्का मैंने लगाया, ठीक है। वो ये अभी देख लेते हैं मार्क स्कीम। ये एक सेकंड, वो स्पेस बार यूज करो, माइक ऑफ कर दो। एक सेकंड।
में और भी तो ऐसे आयंस हैं जो H+ को एक्सेप्ट करते हैं, लोन पेयर्स हैं, तो उसकी वजह से पॉजिटिव चार्ज नहीं इंक्रीज होगा क्योंकि H+ वहां भी अट्रैक्ट होगा।
नहीं, बात में आवाज नहीं आ रही। मेरी आवाज का मसला है, बाकियों की आवाज का मसला?
नहीं सर, ये लोगों ने स्पीकर ऑन किए हुए हैं।
ये एक सेकंड, उस टाइप ही कर लो। अच्छा नहीं, मैं बताता हूँ कि इसके अंदर what I did was, what the guess that I made, not for valine and lysine, for this dipeptide. They didn't tell us what the isoelectric point was in the question. They just told you that electrophoresis was happening at pH 6. अब उन दोनों का तो मैं शक्ल देख सकता था. I can tell what shape they were in, right? But they just told us that pH 6, and they didn't give us the isoelectric point for this thing. So I assumed, okay, let's assume that pH 6, because it is acidic, pH 6 is acidic. So I just assumed that that if the electrophoresis is happening at pH 6, the medium would be acidic for this one. That was just an assumption. That was one assumption that I made. And if this medium
NH3 अट्रैक्ट हो रहा है, तो और भी तो ऐसी स्पीशीज हैं यहाँ पे जिनके पास लोन पेयर है, तो H+ वहां नहीं अट्रैक्ट हो सकता, जिसकी वजह से
कौन से इसकी बात कर रहे हो? नहीं, amides, remember वो organic chemistry में you studied that amides are not basic.
अच्छा, yes,
ठीक है, and you studied उसका जो lone pair था ना, that mixes with the double bond O over here, so it is not basic, or it's like a terrible base. अच्छा, anyway, so I'll just open up, क्योंकि third वाले के साथ बस confusion है. So this question was what one? It's question number 6. For the third one, they didn't give us the isoelectric point, so that was, अच्छा, वो तो उन्होंने बिल्कुल exactly वही दिया. So I mean that is exactly what they also stated. क्योंकि इसके ऊपर confusion थी whether this would be a negative ion or a positive ion. Valine does not move as it is a deuterion, neutral at pH 6.
सर इसमें तो लग रहा है एवरेज लिया हुआ है
नहीं इसको, हाँ, लेकिन इशू ये था कि is valine lysine going to be a positive ion or is it going to be a negative ion, because they didn't give us the isoelectric point. That was the question.
सर पॉजिटिव होगा अगर नेगेटिव की तरफ मूव कर रहा है ओवरऑल इसका।
तो उन्होंने मेंशन ही नहीं किया कि वो नेगेटिव की तरफ मूव कर रहा है, वो तो हमने गेस किया।
इस तरह से नहीं हो सकता कि
स्लाइटली टुवर्ड्स नेगेटिव।
कहाँ लिखा है क्वेश्चन में? तो नहीं लिखा हुआ ना।
नहीं
मैं वो
सर, हम इस तरीके से नहीं अज्यूम कर सकते जैसे आपने अभी किया था कि आपने अज्यूम किया कि अगर सॉल्यूशन इज मोर एसिडिक फॉर इट, तो
मैंने,
हाँ, दो प्लस बनते हैं।
हाँ, that is what I did ना. I just assumed कि क्योंकि सही जो assumption है, that is using the isoelectric point. If you know the isoelectric point, any pH below 9.8 would be too acidic for lysine, any pH above 9.8 would be too basic for lysine. ठीक है, so you can guess whether it's going to be a positive or negative ion based on the isoelectric point.
So when it's going to be more basic, तो सिर्फ एक ही H+ lose होगा C double bond O का on the right side.
So it will become negative ion.
हाँ, तो इस तरीके से हम अज्यूम नहीं कर सकते कि दो H+ बन रहे हैं तो उसको ज्यादा प्रेफरेंस देंगे।
कहाँ पे दो बन रहे हैं?
NH3+ और H3+, हाँ जी।
नहीं, इसके लिए point is the isoelectric point was simply not given. So any guesses you're going to make is just going to be an assumption. ठीक है, so we just made a wild assumption that since the pH is 6, हाँ, ये तीसरे के लिए तुक्का लगाया बेसिकली ना, क्योंकि they didn't give us the isoelectric point.
कैलकुलेट तो करना, क्योंकि आपने बेसिकली एज कंपेयर्ड टू द मार्किंग स्कीम उन दोनों की मिड रेंज की आइसोइलेक्ट्रिक वैल्यू ले लिए।
हाँ, वो तो ठीक है, मैं वो कह रहा हूँ, नहीं, मैं वो तो बात ठीक है, मैं वो कह रहा हूँ कि ये जो वैलिन लाइसिन था ना, ये दूसरी साइड पे भी तो हो सकता था।
Sir, there's
सर
no
लेकिन अगर होता
specific.
सर अगर
मैं इधर देख लेता हूँ, जस्ट 1 सेकेंड। उससे valine lysine and lysine on the right of the cross, ठीक है, relative order of valine and lysine, that's well, specifically they're saying that it goes to the right of the cross. In our assumption, it's also going to the right of the cross, but we did everything the same. But this one was just an assumption. The last one was, okay, I just assumed that the pH is 6. They didn't tell us.
इस पे भी assume कर सकते कि the total overall charge on ये था +2 था और उस पे -1 था, तो ओवरऑल चार्ज हमारे पास पॉजिटिव आ जाता है।
ठीक है, हाँ नहीं ठीक है, that makes sense. नहीं, that doesn't make sense. नहीं क्योंकि ना if the solution for this dipeptide, ठीक है, if the solution for this dipeptide, अब depends, we don't know what the isoelectric point is, ठीक है, if it was for it too basic, तो सिर्फ ये वाला part negative होगा ना, the other part will not react, right? In basic condition में the base will not react, it won't form an ion, so it will form only this part will react and that will become a negative ion and therefore it will move to the other side. So this one I think was just an assumption because the pH is 6, so I just assumed कि भाई वो electrophoresis कर रहा है तो बस उसका pH पे, they didn't tell us what the isoelectric point is, so I just assumed that pH 6 might be too acidic for this. So, and if it is too acidic, then the basic part will react, and this one would form a positive ion. This one would also form a positive ion. So इसलिए that will get attracted to the negative side, and since it's big and heavy, so it's going to travel a smaller distance.
Okay.
नहीं सर, फिर से बताएं क्या चीज़ है बोली, who is more what?
मास ज्यादा है इसलिए वो कम ट्रैवल करेगा, वरना it's the same.
हाँ, it's going to travel to the negative side, लेकिन compared to lysine,
उसका mass ज्यादा है.
उसका mass ज्यादा है, so it's going to travel a lesser distance.
Half the distance, सही है सर, समझ आ गया.
क्योंकि वो charge inversely proportional to mass ना, distance. But लेकिन question overall, is this clear except for this part? The last part was we just made an assumption. We just made an assumption. ठीक है. बस ये एक question आ जाएगा diagram के ऊपर. The diagram would look like this. You'll put the battery. You'll put a trough over here that will have a buffer solution in it. ठीक है. So there's going to be one question on the diagram.
Label भी करना होगा.
अच्छा हाँ, label this. This is the battery and this is a filter paper which is inside glass slides.
सर ये वैसे जेल पे होता है, जेल इलेक्ट्रोफोरेसिस।
नहीं, ये वाला जो है फिल्टर पेपर वाला है, ठीक है, वो thin layer chromatography happens on a gel, not this. और बाकी बस वो है कि that's it. Well, not much of a labeling happening. I'll just see if there's another question. Just a second.
सर बाकी कल कर लेते हैं।
ठीक है, बस ये चलो ठीक है, इसका मैं वो भेज दूंगा, एक मेरे ख्याल से वो था वीडियो थी कहीं, वो मैं भेज दूंगा, ठीक है। चले
कल प्लीज वो एनएमआर और मैथ्स को भी जो आप अगर करा सकते हैं प्लीज करा देगा।
हाँ, मैं वो लेक्चर्स भी भेज दूंगा, ठीक है।
सर विल यू बी अवेलेबल इन स्कूल टुमारो ड्यूरिंग 11 to 1?
मुझे कॉल कर दो, मैं आ जाऊंगा, कोई मसला नहीं है।
सर आप क्रैश कोर्स कब लेंगे? सर कल आप मास स्पेक्ट्रोमेट्री और इसका एनएमआर का,
ठीक है, उसके क्वेश्चंस कर लेंगे, वो स्कूल में मुझे बता देना, कॉल कर देना, अगर आए हुए हो तो मुझे कॉल कर देना।
क्वेश्चंस नहीं, कांसेप्ट भी थोड़ा सा
हाँ ठीक है, वो सारा कर लेंगे, लेकिन वो मुझे बता देना, ठीक है।
ठीक है सर, आपको कल बता देंगे।
ठीक है, ओके, थैंक यू सो मच।
थैंक यू सर, अल्लाह हाफिज़।
चलो